Okay, so we're going to take a look at finding the roots of our polynomial. And what I'm always going to do, finding the roots, finding the zeros, means I'm going to set y equal to 0 first. Actually, that use of roots at the beginning there wasn't quite right. I should have said finding the zeros of this polynomial. Okay, or finding the x-intercept. I'm going to set the y equals 0. Okay, and now you could use the expression, let's find the roots. And I'm always going to try to factor first. Now in this problem there are 4 terms, but thinking about that for a moment, I'm not going to be able to factor by grouping and get the 2 sets of parentheses to be the same. So instead what I have to do is I have to find a root using my calculator. So I'm going to type in my equation. So I'm going to type my equation in, okay, and I'm just looking for a 0. I'm looking for a place where I can be confident that the graph is crossing the x-axis, and I see this spot right here. That looks like that might be at 3. So my question is 3 a 0? Okay, well, in order to check, I'm going to plug it in. Now I'm going to see, does in fact 3 make the right-hand side of my equation equal the left-hand side of my equation? So I'm just going to check that real quick. And it is in fact 0. So this is correct. So that tells me that one of the factors of this expression is x minus 3. That is a factor. Okay? And likewise, one of my zeros is positive 3. Okay? Now, to find my other factors, which will eventually lead me to my other zeros, I need to go ahead and do some division. I need to take 6x cubed minus 25x squared plus 16x plus 15, and I need to divide it by x minus 3. Well, I'm going to go ahead and use synthetic division. So 6, negative 25, 16, and 15. I'm going to synthetically divide here. So I'm just going to continue to follow through. So there I go. I got my remainder of 0. So this is 6x squared minus 7x minus 5. So I can rewrite this expression as x minus 3 times 6x squared minus 7x minus 5. And now I'm going to try to factor this inside part. Billy's method, negative 30, negative 10 and positive 3. Divide them both by 6x. Negative 5 over 3x. Positive 1 over 2x. So I end up with 3x minus 5, 2x plus 1, and my third factor is at x minus 3. So my zeros are 3, 5 over 3, and negative 1/2. That comes from just looking back at my factors, setting each one equal to 0 and solving. Okay, so it's a lengthy process with a lot of steps and a lot of different things going on there. But you can definitely be successful with it. Alright? So going ahead and trying a different example. Okay, I'm going to again try to find my zeros. So I'm going to set my y equal to 0. And I'm looking at this, and this should look vaguely familiar in that I can factor a problem like this with that x to the 4th there and that x squared in the center. I can factor it by trying to find 2 numbers that multiply to 36 and add to negative 13, which are negative 9 and negative 4. And the squared and squared are going to make that x to the 4th, and squared and squared are going to add to that squared in the center. And now taking that a step further, I can factor each of those sets of parentheses. And what you'll notice is that in this problem, I did not have to use my calculator to find a root. I did not have to use synthetic division at all. All I had to do was factor. My answers are right there. Those are my zeros. I have 4 of them, and I found them all because I was able to factor. So that's why Miss G and I always say, try to factor first, because if you can factor, it may be much easier to do so. One last example. Now, this is the hardest type of example. In this example, we're not going to have all real zeros, all real answers. Okay, we should have 3, but they may not all be real. Now, I cannot factor by grouping, so I've got to use my calculator. So I'm going to plug my equation in and take a look at the picture that pops up here. Okay, looks like I might have a 0 or 2, so let's check that. Is there a 0 or 2? Well, that's 8. It's minus 4. It's minus 2. Minus 2. Well, that is 0. So 2 is definitely a 0. So one of my factors is x minus 2. Now, by the way, there's a huge hint in my graph. How many times does this graph cross the x-axis? One time only. So that may give the clue to me that maybe some of those zeros are not real, since I'm only seeing one spot. So let's follow through with my division here. X cubed minus x squared minus x minus 2 divided by x minus 2. Okay, long division. 1, negative 1, negative 1, negative 2. 0 there. Makes a 1 and a 2, a 1 and a 2, a 1 and a 2, 0. So this is x squared plus x plus 1. So in factored form, I have x minus 2 times x squared plus 1x plus 1. By the way, one of my zeros is 2. Now, I can't factor this further. But there's an x squared there. So I've got to start thinking about, well, can I solve that equation? Well, sure I can. Using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's find our discriminant first. 1 squared minus 4 times 1 times 1 gives me 1 minus 3, minus 4, which gives me negative 3. So now plugging everything in, I have negative 1 plus or minus. I'm going to pull that I right out, make that a positive 3 all over 2. 3 cannot be reduced. 2 does not go into negative 1 or 1. So these are my other 2 zeros. Negative 1 plus I root 3 over 2. And negative 1 minus I root 3 over 2. So those are my 3 zeros. 2 of them are complex, while one of them is real.